to begin with, we have Azure DataFrame column. So first thing to understand is what is DataFrame. DataFrame is nothing but a collection of data that is organized into columns. And then we have column expressions. These column expressions are used in DataFrame operations like filtering, sorting, grouping, aggregating, all of that. So we will get started. We'll show you examples of each, and then we will go like that. To create a new resource, create a test and run. Okay, it might take some time for it to get started. I'll start explaining things. Maybe I have the result here. Oh, okay, I have the result. Okay, so what happens is this this is one of function. So the first thing is call. So we already saw how we could um, call how we if you want to use a particular column in our data frame code, we could use the call column expression. So let's say if you use call name, we are just how in SQL Server we just write the column name. We could it's the same meaning here. Yeah.
Okay.
So yeah, this code is like in SQL Server we have case when, right?
Case when. Yep. Okay.
Yeah. So that is what's happening here. So if you have when this is the if condition, and then if this if condition is true, then this is the output that we want to give, and else we should be giving this. So here if you see, I have given when name is Alice, then give the name, else I should give a name. So if you see here, we have Alice, Bob, and Charlie. So we can see the output as only Alice. So this is case when. Now, so yeah, so like I was saying, the first column expression is COL to call a particular column, and then we have EXPR. So what EXPR does is if we have if we want to do any type of transformation to a column, like let's say here if I want to add some number to the existing column, I could use EXPR. So it's nothing but it's saying that this is an expression. I'll calculate this expression and give me the output. That's EXPR. And then we have alias. So alias is nothing but I'm just giving a new name. How we have AS function in SQL. So that's alias. And then dot sort. Dot sort is similar to order by in SQL. So we do the sorting, and then I'm calling this particular column and saying that I need it on the descending order.
So question here, Adarsh, like
yes.
So you have all these functions on data frames, right? So there are each of these things. There are so many of these, all these. You're calling all these methods and all these things, right? My question was like, if I wanted to write this in SQL, how will I write it? Like I'm just trying to, So if you can just show me that, I know it's pretty straightforward. So if you can just show me that, I'll be grateful.
Sure. So what you're basically asking, if you want to do this transformation in SQL, right?
Yeah, in this data frame
Okay.
transformation in SQL, yeah, which is
Yeah.
faster though, also.
Which is what you're asking?
Yeah, so to put the code out
M
in SQL and then show which is faster.
No, this is faster. So PySpark code is faster. Say if you want to use SQL, what happens is you need to first convert this data frame, like how we saw here. You need to first convert it into a temporary view.
Okay.
So that will take time. That is one thing, and then you have to do the transformation on top of this view.
Okay, so there's one more step.
One additional step. Yeah. So that is more expensive. But this is very once you get the hang of it, this is very similar. This
Okay.
is how we do select. By select,
Yeah.
we need the required columns. So
Yeah.
what I'm trying to do in this session is basically relate PySpark code as much as possible to SQL code, so that you will
Sure.
get the hang of it. Yeah.
Okay.
So here we are doing select, and here we are doing sort. Sort is nothing but order by in SQL. Yeah. And alias is AS. Expression is expression is nothing but an expression. It says compute this expression and give me the output.
Okay.
Yeah. So okay. Then column expression can be used with other data frame APIs like we have filter, select, group by, aggregate function, all of that. Then overview of column class and methods. Okay, so column class is used to represent a column in a data frame, and then it's nothing but the column class provides us a way to manipulate the particular column. So we already saw all of these this alias is one of the method of column class. Then inside the sort we could use DESC, ASC. That is one thing. And then here we're gonna see this thing is null. So what this does is it gives us the binary output. So if this column is null, then this will return true.
Okay.
And if that particular column is not null, this will return true. And if it is null, this will return false. So both these will be inverse. And then how we have like statement in the where condition in SQL, we will use like statement. Similarly, we could use it here as well.
Okay.
Yeah. So, that is another thing. So this is how the output will look like. Right now we do have data. So is null will show us false only, and coming to is not null, it will the output will be true. And name like Alice, we have only one Alice. The rest two are Bob and Charlie, so we have only one true.
Okay.
Okay, yeah. So the next thing is in. So what here what happens is by is in we could give a list of values, and this also gives a binary output and ask it to check like if the value is present inside this list, then give me true, else it should be false. So okay, let me add Bob as well, so let's see the change. Okay, so that is about the first thing. Then if it contains air, then return true. Then we could so there is something like between, similar to in SQL how we have between. It's the same logic here as well. So if we could tell column between this particular these two ages,
Okay.
and then it will give us the output. So I'll execute this. And the cluster is not yet started only.
It's taking a long time for no reason, is it?
Yeah, we have Alice Bob. Okay, it should in this case sensitive. Now you see we have two true here. Earlier we had one true because there was only Alice. Now we have Bob as well. So the first one is returning two true, and these are just Boolean output. So it will be like this.
What was the
Okay,
function to rename the columns? Just curious. That was
sure. Alias. So
oh,
I'll
that alias. Okay.
yeah.
Okay.
And one other thing is, say if you wanna download all the rows, you could download all the rows as a CSV file and then do analysis over it. So that you will be using doing a lot often.
Oh, okay. That's very helpful.
Yeah.
A lot of the older SQL, the consoles didn't have that. It used to be very
Hmm.
difficult to validate results from a query. It used to take a lot of
Yeah.
time.
Okay. So the next thing is, this is how we will be casting. So casting to a different data type. So let's see. So to get the schema of a file for a particular data frame, we could use print schema,
Okay.
tf.print schema, and that will tell the age is right now integer. Okay. Now what I'm gonna do is I'm gonna cast it to a different data type, and then we will see df equal to df. I thought we could do star as well. Okay. Mm. Gonna call name and then what age is ambiguous. Age b age. Okay, why am I getting this from two age or what? Oh, okay.
There are two ages there. That's why I think, right? Yeah.
Yeah. Okay, I'll do it again. Yeah. Yeah. So now if you see here, okay, the first one itself is showing as double. Then I'll some changes to it. Yeah. So first is double, and then I cast it to another data type. So that's what you see here. And then I reassign it back to the same data frame. So that is
Oh, you're
the
just gonna put it back into the same. Okay. Okay.
yeah. That's why I did print schema for both, and these are the two schema. First one has had double, change the data type in line 2, and now we have integer.
Okay.
Now this thing, this is how we get the take the substring. It starts from first index and goes through 3. That's about substring. Then yeah, then the next thing that we're gonna see.
Quick
Say,
question. So, I have
yeah.
a question about the schemas, right? I was looking up. There was some way to automatically get a schema without having to declare it, right? What what is that? I didn't quite understand that clearly. So there's some way to just automatically get the schema without declaring it.
Yeah. So the actually to get for the schema, there are 3 ways to get the schema.
Okay.
So the first way is it infers the schema on its own,
Yeah, that's what I was talking. Yeah.
and yeah, then the second way is this thing where we could define our custom schema, and the
Hmm.
third way is using Scala code we could get the schema.
Okay.
Yeah, that is using Scala we could do that. But yeah, right now I don't have that on the top of my head because I don't use this much often. But I'll look it up and give that to you in next session.
Which one is the usual best practice to define the schema, right? Because that way you can
Def-
control it.
Yes, defining the schema. We ourselves will be defining the schema and then making the changes. So mostly I use this only, the defining schema.
So when it infers the schema, what does it do? It will just review the columns and see if this is a number or if this is a double or this is that text. It will convert that, right, based on that, right?
No, if it's a CSV file, everything will be string data type.
Oh, so even when it's inferring the schema, it will do just it'll put everything as string.
Yeah, so whatever data type is there in the source, it will take that. But let's say that's for CSV file. Let's say in Parquet, the data type will be tied along with the data in the source, as in Parquet files. So when it infers schema from Parquet, it will take. It won't do anything. It will take whatever is in source. It will take that.
Okay.
That's the whole idea. If you want to have control, we could define the schema, and we could get the schema from the source as well, and then make changes on top of it using Scala. But yeah, this code I'll show it to you tomorrow.
Sure.
I have it written
Okay.
somewhere in my notes, but yeah, I don't remember that. Okay, so then coming to substring. So substring is similar to SQL. Starting index is this one, and then ending index is this one.
Yeah.
Then yeah, okay. So this is important. So this is how you add a new column. Now we have a scene. Okay, so df dot with column. Here you're adding a new column. This will be new column name, and what should be the contents of the new column? That's this one. So here what I'm doing is, so let's say if you wanna add a new column, and then all of the column value should be constant string. Let's say you wanna add a new column, and the contents of the column should be high. All the columns should have high as string. So in that case, you should use literal value lit, and then give your particular string here. This is to add constant string. That's lit. So here what I'm doing is I'm using concatenate function, and then I'm concatenating my name, and I'm giving between a name and this particular column. Lit new. I'm between name and the literal value. I'm concatenating, and then giving this as a new column. That is happening here.
Okay. So you're basically
The,
concatenating a column name with a literal string. That's what you're doing
yeah,
with the literal value.
correct,
Okay.
correct. Yeah. So that is happening there, and then here we're gonna see. Okay. So here we are filtering our particular data frame, and we are giving the filter condition. This is something that you will be using very often. So these two, adding new column. Let's say if you want to replace the existing column with a new column, you could just give that here. Let's say I'm gonna replace name with a new name. So that's what happened here. To replace the existing column also, you could use this function. Just give the same column name here, that will replace. Or if you want to add a new column, you can do that here.
You just change name back to name, or
No. So
when you
here,
did.
right now what happened? Okay, right now what happened is I added a new column. Okay, and
Okay. Yeah.
uh, let's say now what I want to do is I want to change this. I want to replace this column with the new values. So I gave the same column name as this one, and then if I execute, it renamed, as in it replaced the old uh, column with a new column. That is with
Oh.
column
Okay.
function. Yeah. So the next thing is filter. So filter is like the where condition in our SQL. So it is very how do I put it? So
Yeah. This is straightforward. Yeah.
let's yeah, it's very straightforward. So and this also you'll be using very often. And if you want to combine two values together. Yeah. If you want to add, this is like and in our SQL. The only thing is you should, yeah, two condition. You could give and here, and the only thing is you should encapsulate both of this in brackets before you use the and. So this notes, this is one condition, the other one is one condition. Then let me see, give me 1 second. Okay. So similar to filter, we could use where. So the only difference is we need to give include all of this inside single inverted commas. So here I'm using where, and here it's different. So and I could use
Oh, like that. Okay.
so this will be very similar to SQL. The things you have to use two equal sign here. Yeah. So if you have to include all of this in single inverted comma, and if you're using string inside, you have to give double inverted comma inside.
Oh, okay,
So
because it's
that's
a string
we
within
shall
a string literal. Okay.
correct. So that's with where condition. Yeah. So the next thing is similar to how we saw earlier. We could use is in and then give a list of values, and if the values are inside this the list, then only return the value. So the thing is, these uh, the 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 functions with the list, you have to be careful because those things you will be using more often, because we could integrate PySpark with Python. So using Python, because there might be something that in your project where you get the values inside a list. Then if you want to do manipulations from, you could incorporate that list inside your PySpark code. So that is what happened here. So let's say I have 25 age here. So here now you can see we have two output. So what it does is it checks if the age is within the values that's present here. If it is, it will give us out.